In this video, we will explain about the origins of the elements. Imagine you're in a park, looking at a leaf on the branch of a tree. We know light bounces off the leaf to your eye to tell you that it's green, but how exactly? Before we go deeper into this, let's turn the lights on. Once upon a time, nothing existed. Literally, nothing. But after this happening that we call the Big Bang occurred, there was something, our universe. This all happened around 13.7 billion years ago. Scientists call the period before that singularity. The cause of it and where it came from is still unknown, because we can barely understand fully what a singularity is, as it rebels against our understanding of physics. Let's say it's just not inside our dictionary. The closest we can compare it to are black holes. Areas of gravitational pressure where there is no gravity, no nothing. Once again. So coming back to the Big Bang explosion, which is a common misconception, as there was no actual explosion, but more of an expanding. It started inflating and just forming from something really small and hot to something way bigger and to the temperature of our universe. Technically, it is still happening at this very moment, while you are watching this video. The universe keeps expanding and cooling. Back to the question, but what is light? Short version, light is the energy coming from the sun in magnetic and electric waves. These waves are therefore called electromagnetic waves. Light waves behave in four ways: reflection, refraction, diffraction, and interference. But then there is the question, where does light come from? Because that doesn't just happen or start existing out of nowhere. Light is formed by energy, and there is more than enough energy found in our universe. To explain how atoms create light, let me show you a little picture. It kind of looks like our solar system. The center is like our sun, the orbitals represent the energy levels, and the blue ball is like our planets. At first, the atom is in a stable form. Once it starts absorbing energy, the electrons, sometimes one or sometimes more, are being kicked further away from the nucleus to a higher energy level. In doing so, the electrons get excited. However, these atoms are unstable and try to get back into the nucleus. A little fact, these waves travel a distance of 300,000 kilometers per second from the sun to the earth in just 8 minutes. Now that we know what light is, we will explain about suns and stars. So stars are actually the places in the universe where the elements were created. What we call our sun is also a star, technically a big ball of fire. We could also call all the other stars suns, but well, the only difference is that our sun is the closest star to our planet and all the other stars are billions of miles further away. Simply saying, a star is a big ball of gas. Stars come together in places where there is gas in abundance. This gas is pulled together by gravity and forms these balls. Example is the Orion Nebula. Most of its life, stars are fusing elements. For example, hydrogen with hydrogen, which makes helium. This makes the star very hot and puts a lot of pressure on the stars. The pressure makes them heavier, and when the star can't hold it anymore, it explodes. This explosion is called a supernova. When a supernova happens in a nebula, it releases gas and more pressure. There are multiple kinds of stars. Small stars live up to 100 billion years and do not explode, they just dim, also called red dwarfs. But then there's the red giant star, which comes to life when a star's core gets hot, pushes the outer part away, and makes a red giant star. An average star pushes gases away. When it explodes, the core remains and it becomes a white dwarf. When it dies, it's a black dwarf. Larger stars explode, which pushes gases away, and the only neutron stars remain. If the star was very heavy, it will become a black hole, in which the gravity is so strong light can't even escape. Now the last thing we need to explain before going into the origin of the first elements is the atom model. Atoms consist of protons, neutrons, and electrons. Dalton was the first person to find out about atoms in 1803. He thought that atoms were just round balls. But guess what? He turned out to be wrong about this because Rutherford found out in 1911 about protons, neutrons, and electrons. 2 years later, it was discovered that Rutherford had also been wrong because of his own student, Bohr, who found out in 1913 that the structure was a little different than what his teacher had thought. Nowadays, we use the model that Bohr made, and we consider this to be the right one. Now that we know about atoms and the atom model, it will be a bit easier to explain how the first elements were created. We all know about the periodic table, or at least you should if you're watching this video. If you don't, it is a scientific table naming all the elements discovered so far, and naming the number of protons and neutrons that it contains. The first element in the periodic table is hydrogen, and that's because it's the simplest one. If you add up 2 particles of hydrogen, you get helium, a slightly more complex element, but in comparison to others, still very simple, and so it goes on until we get all the elements that exist nowadays. More complex elements go through way more complicated processes, and that is why they are also more rare. Instead of an element being more or less complex, we talk about the atomic number, the number of protons. Hydrogen only has 1 proton, and that's why it's so simple. The largest number of protons found in nature is plutonium, which has 94 protons, but is a very dangerous substance because it's radioactive. Another thing to take in mind is the number of neutrons. 2 different atoms can have the same number of protons but different amounts of neutrons. This is called isotope. But now that we have arrived at the end of this video, I hope you have learned something from us, because you never know if you will become the next scientist to discover something new about atoms or find the new most complex element on Earth.